Welcome friends. Now let us solve few more problems by using stiffness method. So let's consider a problem of fixed beam. So there is a change in cross section at C. So for AC EI is 2EI and for BC it is EI. Value of I is I. Here it is 2I. Now both the ends A and B are fixed, means there is no unknowns at A and B. Both deflection and slope at A and B are 0, but there is a cross section, there is a change in cross section at C. Let's consider unknowns at C, delta C and theta C, vertical deflection at C and a rotation at C. So let this indicate delta C equal to D1 and theta C equal to D2. Let's assign the coordinates in the direction of unknowns. So D1 is in the direction of delta C and D2, that is a rotation, is in the direction of theta C. So two unknowns, two coordinates D1, D2 are assigned in the direction of unknowns. Now next, see, obtain the restraint structure. Let's obtain the restraint structure by locking all the joints. So joints A, B, C are now locked. A and B are already fixed. So let's lock the joint C, make it fixed. So this is called a restraint structure, and calculate the restraint actions. Now these restraint actions will be due to the member loading. Actually the 50 kilonewton load and 25 kilonewton meter, that concentrated load and bending moment, they are acting in the direction of unknowns. They are called the original actions. That is AD1 is equal to 50, that is D1 is downward, 50 kilonewton is downward. So 50 kilonewton acts in the direction of D1, same direction, therefore positive. Then AD2, that is in the direction of D2 also we have a bending moment 25 kilonewton meter. D2 is clockwise, moment is also clockwise. So AD2 is 25. So these are called original actions, that is the actions given in the direction of unknowns. Now, or in the direction of joint displacements. Now restraint structure we have obtained. Member load is 12 kilonewton per meter. So these are the joint loads. Now 12 kilonewton meter is a member load, and the fixed end actions. At left end we know the fixed end moment developed is WL square by 12 anti-clockwise, right hand WL square by 12 clockwise. So WL square by 12 gives us 16, here also 16, and then the reaction, since loading is symmetrical, the reactions will be total load divided by 2. So reaction will be 24, 24. Now these are the reactions. Now say, that means we have to calculate actions corresponding to D1 due to load, action corresponding to D2 due to load. Say our D1 assumed is downward, this action, that is reaction, is upward, therefore negative. AD1L is negative. Or you can write here separately also that your AD1L is minus 24 and AD2L is 16, that is plus clockwise. So that D2 is clockwise, therefore this is 16. Now in the next case we have to find out the stiffnesses. Now stiffnesses by applying unit displacements. Let's apply a unit displacement in the direction of first coordinate, that is D1. D1 is a vertical downward, so apply a vertical downward deflection of unit. So this unit deflection is to be applied. So vertically downward. This is just like a sinking of support. For this span AC, the right support goes down. So both end anti-clockwise moments developed will be 6 EI upon L square. So here value of I, substitute corresponding value of I equal to 2I. After substituting I equal to 2I and the span, you will get 3 EI by 4. 3 EI by 4, and both end anti-clockwise. And each reaction will be this total moment, that is 3 EI by 4 plus 3 EI by 4 divided by 4 gives us 3 EI by 8. And the total moment is anti-clockwise, reaction must form clockwise couple, equal and opposite. Similarly, here also both end fixed, left support is down. So clockwise moments at both ends developed will be 6 ei delta upon L square. Delta is 1. Substitute for I is I. L is 2. Substituting for I and delta, so you will get fixed end moment 3 ei by 2, 3 ei by 2, right? Then the reactions will develop equivalent opposite couple. Total moment here is clockwise. Reactions must develop anti-clockwise couple. That 3i by 2 plus 3i by 2 divided by 2, and that gives us again 3i by 2. So reactions are 3i by 2. Both these reactions are downward. Now what is K11 and K21? So in the direction of 1, because both are downward, so directly you write here, or you can take separately one. So if you want to write down separate, then this K11 equal to this plus this, both are downward. This is 3ei upon 8 plus 3ei upon 2, and this gives us, this is 8, 15ei upon 8. This is 15ei by 8. This is K11. Then K22 is equal to this anti-clockwise negative minus 3ei by 4, and this is plus 3ei by 2. So this is equal to, say this is 4, 3ei by 4. So you will get 3ei by 4. So this is positive you will get. So this is K2, sorry, this is K21, not 22, this is K21. K21 is 3ei by 4. Now next here again, see here we have to apply a unit rotation in the direction of D2. So at the joint B is to be rotated clockwise through unit on both the side. So therefore here it is developed a 4ei by L is 4, so we will get 2ei, half of that further end ei, same sign clockwise. Here also 4ei by L, that is 2, you will get again 2ei, half of that ei with same sign. Now this is clockwise, reactions must form anti-clockwise couple. So each reaction here you will get 3ei by 4. Similarly, this side total is clockwise, reactions must form anti-clockwise. So 3ei by 2, 3ei by 2 you will get each reaction. Now let's calculate the coefficients. K12, this is K12. So this is upward and this is downward. Upward is negative, that is minus 3ei by 4, and downward plus 3ei by 2. So you must get same, that is 3ei by 4. So these two values must be same, because K21 must be equal to K12. That is the property of stiffness matrix, it should be symmetrical as well as square. Then the last K22 is equal to, so this both are clockwise, this is 2ei plus 2ei is equal to 4ei. So this you will get 4ei. That means this actually this is K11. Both are positive and this value comes out to be 15ei by 8. And what is K21? This is K21. So this is minus and this is plus. So this is anti-clockwise, this is clockwise. So you will get K21 as 3ei by 4. Then this is in the direction of 1 due to 2. K12. So this is minus, this is plus, and what you get is 3ei by 4. So this is 3ei by 4. So this 2 must be, and this K22 is equal to, both are positive, 4ei. So even directly you can find out all these coefficients directly on the beam, or you can calculate separately. So as for your convenience. So now all these coefficients are to be multiplied by D1 while writing down the equilibrium equation, and these are to be multiplied by D2. Now once we get all these stiffness coefficients and fixed end actions. Now let's use the joint equilibrium equations and find out the unknown d1 and d2. So first equation, a d1l plus k11 d1 plus k12 d2 is equal to a d1. So a d1l is minus 24 plus k11 is 15 ei upon 8 d1 plus k12 is 3 ei upon 4 d2 equal to 50. So you develop first equation, and the second is a d2l plus k21 d1 plus k22 d2 is equal to 25. So is equal to 25. So this is equal to a d2 is L is 25 plus k21 is 3ei by 4 d1 plus k22 is 4ei d2 equal to 25. So simplify this and obtain the second equation. So now two simultaneous equations are developed. Let's solve these two equations by using matrix approach, or as usual, even you solve the equations as usual, two simultaneous equations. So solving equations 1 and 2, find d1 and d2. So d1, d2 you will get. So these two quantities you find out. So after solving about two equations, and once, see, our problem is to find out fixed end moments at A and B. And reanalysis means vertical reactions and fixed end moments you have to calculate. Now what is MA then? MA is equal to, so here, so MA means this sum. So let's take sum, this sum is to be taken. So this gives us MA. Only end moments. This is minus 60. This is again anti-clockwise. So minus 3 ei by 4 into d1. This is plus ei into d2. So this is minus 60 minus anti-clockwise 3 ei upon 4 d1 plus, this is clockwise, ei d2. Just calculate, substitute and find out the MA. Then MB is equal to bending moment at support B is given by MB is equal to, now here this end, now there is no fixed end moment, this is clockwise 3ei by 2 into d1. Now this, only this you will get. So this 3ei by 2, only end moments are to be taken, this one and this one, multiplied by d1 multiplied by d2 plus ei d2. So this gives us the fixed end moments at A and B. And now the vertical reactions, once you get the moments, then vertical reactions RA and RB can be calculated by using equilibrium conditions. If you take moment about A, then you will get RB, and summation Fi equal to 0, you will get RA. So knowing RA, RB, MA, MB, you draw SFD and BMD. So the further calculations you complete. Once you get the fixed end moments, calculate reactions and construct SFD, BMD. Okay, now one more problem we will see by using stiffness method. Already we have solved two problems on this during previous lecture. Now one more problem of continuous B. So that we will cover the varieties, various types of problems. So now let's consider a continuous B. Say this is fixed. Take this as a continuous support, maybe a roller, and here say a concentrated load 20 kilonewton, and then you take UDL. Say I am taking Y12, it becomes easy to do the hand calculations. Otherwise, any value you can take. Any value may be given. So 40 kilonewton, and say this is 2 meter, this is 2 meter, say this is 4 meter, and say you take this as 1 meter, 1.5 meter. So these are the span lengths. Say beam is A, B, C, D. Again, the independent joint displacements are to be considered as unknowns, means theta B and theta C will be the unknowns. Let theta B equal to D1, theta C equal to D2 be the unknown displacements. Now assign the coordinates independently, or even in the same problem, if you assign the coordinate, say this is D1, say this is D2, that is also okay. No need to consider the beam separately. Now let's say equivalent beam. For such, if there is a overhang, it's better to consider equivalent beam. Say due to the load acting when the moment here is 30 kilonewton meter, and this is 12 kilonewton per meter, this is 40 kilonewton. So 2 meter, and 4 meter. So we consider equivalent B. So let's consider equivalent B. And here the original action, say what is AD1 is 0, AD2 is 30. So this is nothing but AD2, and there is no concentrated moment acting here in the direction of D2. So original action is in the direction of second coordinate, that is in the direction of D2. Now next, let's find out fixed end moments. Let's find out. So log the joints, log all the joints, and then this is 40 kilonewton, and this is 12 kilonewton per meter. So what are the fixed end actions? Here it is anti-clockwise, here it is clockwise. WL by 8, L is 4, so this will be 20, and this will be 20. Then here, this is anti-clockwise, and this is clockwise. So anti-clockwise WL square by 12, 12 gets cancelled, L square means this is 60, and this is also 60. Now this is a restrained structure. Now in the direction of first, now no reactions are required because we have unknowns, only slopes, only moments are required, actions, moments are required. So this is in the direction of 1 due to loading. This is plus, this is minus, so this is clockwise is positive, anti-clockwise negative, so this is 4. 20 minus 16 is 4. And this is AD to L, that is plus 16. AD to L is plus 16. So what is this step is restraint, we can say actions or restraint structure, and we have calculated actions. Now in the next step, let's give so keep it fixed and give unit here rotation, say this is clockwise 1, clockwise 1. Clockwise rotation unit is to be applied at joint B. Therefore here you get clockwise moment, this is 4 EI by L. L is 4 gets cancelled, so you will get EI. Here also 4 EI by L. So L is 4, and further end half of this, that is EI by 2, and here also half of this EI by 2 with same nature. Now what is this K11 and K12? So K11 is EI plus EI. So this becomes 2EI. K11 is this, and this is in the direction of 2 due to 1. K12, all these are to be multiplied by D1. All these are to be multiplied by D1. Now next, only no reactions required because our unknowns are rotations. So next, say keep it fixed, and allow rotation here, in a clockwise direction in the direction of D2. So this is 1. Once we allow the rotation here, then the clockwise moment developed here is 4 EI by L is 4 gets cancelled, simply EI, and here it is EI. So this is in the direction of 1 due to 2, this is in the direction of 2 due to 2, and all these are to be multiplied by D2. So this gives us the stiffness coefficients in the direction of D1 and D2. The problem is very simple, only thing is that we have to obtain an equivalent to B. Now using the equilibrium conditions, say AD1L plus K11D1 plus K12D2 equal to AD1. So this is 0 plus K11 2EI D1 plus K12 EI D2 equal to 0. So very simple first equation is 2D1 plus D2 is equal to 0. Equation 1. Just a minute. We have AD1 as 4. So this will be, the equation will be minus 4 upon EI. The equation will be minus 4 by EI because AD1 is 4. Now second equation, AD2L plus K21D1 plus K22D2 is equal to AD2. So now substitute AD2L is here, that is positive, again 16 plus K21 is EI by 2 D1 plus this is EI D2 equal to 30. Now just simplify this multiplied by 2 we can do this way. So let's multiply it by 2 everywhere. So this will be D1 plus 2D2 equal to 30 minus 60, 14 into 2, 28. So 28 upon EI. Equation 2. So D1 plus 2D2 equal to 28 divided by EI. Now solving 1 and 2, it's simple one. 2, 1, this is 1, 2, D1, D2 equal to 1 upon EI. This is minus 428. Minus 428. So matrix equation now we have developed. Now next let's solve this. This is D1 D2 is equal to 1 upon EI, and let's solve this 3i. It becomes 1 by 3i, and then this is 2 minus 1 minus 1 2, and this is minus 4 28. Okay, you will get d1 and d2. So you find out d1 d2. So you calculate d1 d2. So this is theta b theta c by solving this matrix, and then MAB equal to, right? Now MAB, so here anticlockwise, so minus 20 plus EI by 2 D1, and MBA equal to plus 20 plus EI D1, that's all, and MBC equal to minus 16 plus EI D1 and plus EI D2. So these two you will get equal and opposite. So you find out these moments. So after getting this, you just construct BMD. Even if you want to find out MCB, what is MCB must be equal to this 60 plus EI by 2 D1 plus EI D2, and you must get this as 30 kilonewton meter. Remember, because your MCD is minus 30 kilonewton meter. So these are the moments, and with this moments you construct bending moment diagram, find out reactions, and then complete SFD. So now we'll stop here. During further lecture, next lecture again we will solve one or two problems on frames we have to solve. Okay, thank you very much.